Hello, welcome to Devops with Prasanna. This is day 4, and today we are going to talk about Route 53 and the AWS Certificate Manager. This is very important topic because it's going to cover the end-to-end picture, and there are a lot of interesting topics to discuss as well. Yeah, so let's dive in. This is the demo which we are going to look. This is the demo which we are going to set up. But before going into this demo, there are few concepts which you have to understand. The first one being like DNS. So DNS stands for Domain Naming System, which means for example, you have a domain. Someone has to convert that domain into IP address. To give an example, let's say you have google.com. Someone has to convert this google.com into actual IP address, which you have seen in the previous sessions. If you see, the EC2 instance will be having a public IP address. Similarly, load balancer will be having its own IP address and things like that. So this is going to convert google.com into something like 10.150.11.130. So this system is called as domain naming system. And Route 53 is nothing but a managed DNS system. So AWS is handling everything for us. We just have to do the configuration part. And there are few more concepts as well. So we'll go into the concepts. For example, in the domain name, let's take one more example, and this is what we are going to see in the demo also and in all the lectures. So the site is called superstats.co. It is my site. I created a microstats for a different purpose. So we are going to use this site. You can see the domain name is superstats.co. This .co is called as top level domain. And there are like different top level domains. For example, you would have seen something like google.com. .com is a top level domain. Something like tce.edu. That edu is a top level domain. So there are like various top level domains. And next comes the second level domain. Second level domain is the actual domain, like superstats.co. And like there is one more piece also, which is called as subdomain. So in this case, www is a subdomain. And if you see, there is a naming convention called FQDN, fully qualified domain name. So if you give something like the full name, that is called as fully qualified domain name. That is also a terminology which we'll be using. So this is about the domain names. Okay. So the reason I mentioned about various levels of domains is, let's say we'll see how the things work. For example, you are opening your web browser and you are going to type www.superstats.co. This is what you are going to type in the Chrome. Okay. So if you type this in the Chrome in your machine, first it will check in the local DNS server. So all the machines will have a local DNS server. It will first check if the domain has any corresponding IP address or not. If it has the IP address, then it means the IP address resolving has happened within the local itself, and the local machine itself will return back this is the IP address. Let's say like I'll mark it as IP. So it'll give back this is IP address, and browser will render the page correctly. Let's assume a case where in our local the IP address is not present, which means a mapping of for this domain name, this is IP address. That mapping is not present in us. So what DNS server in local will do is it will see the top level domain. For example, in this case, top level domain is .co. It will take the co and then it will query the TLD server, like top level domain name server, the top level domain server, DNS server. It will query the top level domain DNS server. These are maintained by different foundations, like ICANN and different foundations are maintaining the server. So we'll query this information and then we'll get back something called as NS record of second level domain. So this is also like one more name, like one more nomenclature which we have to understand, which is called as NS record. NS record stands for name server record. So name server record is nothing but the location of another DNS server. So that is the idea. For example, this TLD will give the location of another name server. So it will come here and then this will query the second level domain DNS server. If you, for example, it will query with superstats.co, and then luckily in this SLD we got the information, so it will return back whatever the record it is. So there are two type of records which we can get. Either we can get a stream name record or we can get a AA record. So this is also something which we are going to discuss in depth. But the catch here is somehow this DNS server will give back the information that for this domain you should have this as a IP address. And this IP address information will be received in the local DNS server, and it will cache that information for the particular time span. That time span is called as TTL. So it will cache that information for that TTL period, and then it will return back the information to browser again, and then browser will render the page. So this is what happening when you type something in the web browser. Now the interesting part is we talked about three type of records here. One is NS record, the other one is CNAME, the other one is A record. We'll just take a look at these record types. There are like a lot more record types, but we'll just stick to this because these are the most foundational ones. The first one we'll talk is this NS name server. As I mentioned, this name server is nothing but uh, information which will have the list of domain names and then IP address mapping. IP address, or we'll call it as records in general. Okay. So this name server will give back those information. Okay. For example, like even AWS is a name server. So which means it will have its own NS records, and then this name server will maintain some list like what are the domains available and what are the corresponding records available. For example, this will be something like name and then record, and then record type also. Record type will indicate whether it's a CNAME or A record. Yeah, maybe like if I show you an example, I think you'll understand it in a better way, like what this name server is. And coming to the CNAME, it is nothing but like it's called as canonical name, so that's why it's CNAME. It is nothing but um, alias in the sense, for example, if you give a host name, it will give back to you the host name. For example, let's say superstats.co. So if you say superstats.co, it is nothing but alias of, let's say, another site, something like monits.co. Okay, which means like for this particular domain, you are getting back a domain again, not an actual IP address. Okay, because it's going to be alias. And then what the name server will do is like it will query for this monits.co, and finally it's going to end up at the IP address only. But in between, like this is just a redirection. Like this is a like from superstats.co, you're getting the monits.co as a one more domain. So this is called as a canonical name record. And A record is nothing but the IP address. So this is the actual address value. So if I give superstats.co, it can give something like 10.11.120.18, some IP address like this, which will be the actual IP address of the server. So that's what we'll get in the A record. So these are the records which we are going to configure. There is like one more special record which is called as alias record. This is very specific to AWS. So why this is used? Like what is the difference between these two things, canonical name and alias record is? Alias is nothing but an alias for the AWS resources. For example, if I say superstats.co, the alias record could be a load balancer's DNS name. So if you remember, like in the last session, we talked about load balancer, and each and every internet-facing load balancer will have a, DNS like domain attached to it, and that domain is publicly accessible. So in this case, if we have an alias record, then we can directly choose the load balancer's domain itself. So that is the idea. Maybe like this also something which I'll show in the demo part. But these are the four type of records which you have to understand. Now what I'll do is, I think this looks good. We tried to cover most of the things. Now we'll come to the actual Route 53. Okay. So as I mentioned, like the managed DNS, AWS managed DNS is called as Route 53. Why this 53? Because by default the port for DNS server is 53. So that's why like they mentioned the service name is Route 53. in Route 53, you have to understand few concepts. Like the first one is hosted zone. So this is hosted zone is like uh, the collection of records, like collection of records. Records in the sense it could be like a record, CNAME record, name server record, whatever it is. But this hosted zone is a collection of records in AWS. So first you'll create a hosted zone, and once you go inside the hosted zone, you will get something like you can add a few more A records, CNAME records, and things like that. So in this demo, what we are going to do is we are going to set up this Route 53. We are going to use a load balancer from yesterday's session. So this load balancer, it will be having two EC2 instances, and this load balancer, like we are from the DNS, we are going to forward the traffic to this load balancer. This load balancer will forward the traffic to the corresponding EC2 instance. So that's what it is going to happen. Yeah, and there is like one more concept which you have to understand, which is the domain register. I didn't mention about this here, but I'll write it here. Domain registrar. So what is meant by domain register? For example, we are talking about something called superstats.co, okay? Which means I am the owner of superstats.co. So how I'm saying I'm the owner? I gone to some domain registrar and then I bought this domain from them. So for example, in this case, I use a domain registrar called Namecheap. And there is like one more popular domain registrar called GoDaddy. So there are like lot of domain registrars. Even this Route 53, they also provide the domain registrar, which means you can check for some domain, like whatever domain you want, and you can buy it from Route 53 itself. So in this case, like I'm using Namecheap, which means they are the owner of this superstats.co domain, and they are giving it to me for like particular time period, like for 1 year or things like that. And I have to renew this domain for each and every year. So that is the idea. Okay, so why I mentioned about domain registrar is, let's say like if I want to configure something, this domain registrar is a place where I have to manage all the DNS information. But when we are using Route 53, what will happen is in the domain registrar, I'll add one more redirection. If you remember, like we talked about this redirection here. So it will give the DNS record value and then it will go to a different DNS server. So in this case, I've gone to Namecheap domain registrar and I said like I don't want to maintain any DNS records with Namecheap, but instead I want to maintain all the DNS records with Route 53 itself. So which means in this domain registrar, I've added the name server of AWS. So whenever a traffic, like whenever the redirection comes here to, for example, in this case, Namecheap will again send the NS record of AWS Route 53, and the traffic will be sent to Route 53, where the actual resolving happens, like whether the A record or CNAME record, whatever it is, it will happen at the Route 53 level. So this is the idea. I think this looks cool. Now I think we are very good to get into the hands-on part. Yeah. And there is one more thing which I want to mention before going to hands-on demo. Please consider subscribing to my channel if you haven't subscribed already. I see like the subscribers are going like increasing, but it's not proportionate to the traffic which I'm seeing. So yeah, please, it's a request from me. And yeah, if you find the like information is very valuable, also please add your comments, like how my teaching method is, if I want to change anything or not, and whether you could able to understand it or not. So these are some of the motivating factors for me. Yeah. Okay, cool. So first, before diving into the demo, I want to show the setup which we already have. I'll go to EC2. You can see there are two instances running, which are from the yesterday's class, day 3's class. And there is one load balancer which we have. And this load balancer is the DNS of this load balancer is this. So now you will know like what the DNS is. For example, in this case, if we say http:// This is a DNS name, and if you see like DNS is coming from .com is a top level domain, and then it has like Amazon AWS as a second level domain, and all other things are like subdomains. So it has like lot many parts to it. But the objective here is somehow the DNS resolving happened, and then like I could able to see what is the actual information is. So this is cool. So we have set up all these things. If you haven't watched this info, like if you haven't set it up the load balancer, please watch the yesterday's video and set up the load balancer. Now what we'll do is we'll go to Route 53. Yeah, so this is Route 53, and if I go to dashboard, I see there are like no information present here. So like this is the registered domain. If I want to purchase a new domain, I can go here and purchase a domain. But in this case, I don't want to do that because I already have a domain. Maybe I can show you this also. Okay, yeah, I think like okay. So this is a Namecheap which I mentioned, and in the Namecheap I have only one domain which is called superstats.co, and this domain is currently active. So if I say superstats.co, you can see my website. So this is a website, and that we are going to add one more subdomain to it and redirect the traffic to our application. So that's what we are going to do. So like before, like I think I don't want to use this one because it's already configured in another AWS account. So I'll go to this account and I'll show you like what it is there. So I've created one hosted zone. So I'll go here and then I'll say create hosted zone and I'll give the name. So this name should be exactly what we have in the domain. So for example, in this case, it's superstats.co, and it should be public hosted zone. If you select private hosted zone, it's only for the internal use. Like you can route all the internal traffic, which means it is routable within the VPC only. But I'll be choosing a public hosted zone, and I'll be just creating this one. I'm not creating it here because I already have one more AWS account and I have all the things set up here. So this is a superstats.co hosted zone. So as we mentioned before, a hosted zone is nothing but collection of records, DNS records. So in this case, you can see there is superstats.co, which is having a record, and this is IP address. This IP address is nothing but Vercel's IP address. So I'm using a service called as Vercel to do all these things. But in our case, what we want to do is create a record. So I'm going to show you two different types. One is using the canonical name. The other one is using the alias name. But I'm not sure if I can use alias, but let us see. So I'll say learn AWS in 30 days. Okay. So this is going to be my subdomain, learn AWS in 30 days dot superstats.co. This is not a record, it's going to be a CNAME record. So if it's a CNAME record, it has to be a domain because it's going to be like a redirecting to the another domain. In our case, the domain name is, this is our domain name. So I'll remove all the HTTP and I'll just give the domain name here. And TTL is a time period in which the DNS cache will hold this value. So in our case, I'll just make sure it's very small, just 60, which is 1 minute, 60 seconds. And I'll leave all the other things as it is. Okay, cool. So there are a lot of information, but this is what we are interested in. If I select this, if I say http colon slash slash learn AWS in 30 days superstats.co, we can see it is getting the actual information from the server. So how this is happening is from Route 53, it is getting a CNAME record. That CNAME record is a load balancer CNAME record. From that load balancer, it is reaching the EC2 instance and coming back again. And it'll be like doing the load balancing also in the round robin fashion. So that will happen as well. This is great. So we completed the first half of the demo here. I think like this portion is complete. Okay, but the catch here is if you see the Chrome browser here, you can see it is the connection is not secure. The reason is we are using a protocol called HTTP. So HTTP protocol is not a secure one. You should use something called as HTTPS. So we'll quickly see like what is this HTTP, HTTPS, and then we'll go into the demo for setting up that as well. So HTTP, this is HTTPS. This yes stands for security. So what this means is if your traffic is sent in a plain text, it is not secure because, for example, if there is some kind of intruder in the sense who's watching your network, he could able to like read the message and he could able to understand what you are sending. Let's you take an example where you are sending your bank details, okay? Like you are entering your username and password. So if you enter your username and password in a site like this, anyone can do a packet sniffing and they can get your username and password and they can log in to the bank site using that username and password. So you should never do this, share your credentials or important information in a site like this, in HTTP site. Instead, you should always be using HTTPS, which is a encrypted site. So encryption in the sense, first the client and server will agree upon some kind of key, encryption key. Once it is agreed upon, the client will encrypt the message and then it will send the information to server. No one can decrypt that message. So even if someone got the data, they'll have only the encrypted information, not the actual plain text information. And once the information reaches the server, it will use that same key to decrypt the information and then can read the information. So that's what the HTTPS layer is. And here we'll talk about something called as PKI infrastructure, which is public key infrastructure. So public key infrastructure is like it's nothing but I don't want to go into a detail of like how things work and all those things because it's going to be like a very big topic. But what I want to talk here is from the load balancer perspective or from our use case perspective how things work. So for example, we have a client. In this case, client is nothing but browser. So from the web browser, we are going to hit, let's say like learn AWS in 30 days .superstats.co. When we hit this one, first it will talk to the corresponding server. In our case, the server is load balancer. It's not the actual EC2 instance we have. This load balancer is going to exchange the keys, public key and private key, with the client in a secure way. And then once the key exchange is complete, the browser will send the information in the encrypted format. So the request is sent in encrypted format. And there is a concept called as SSL termination, which means all the SSL traffic, SSL in the sense the encrypted text. So all the SSL traffic will get terminated here, this point itself, and it will be decrypted into a normal plain text, and plain text will be like redirected to the machine EC2 instance. So this is what's going to happen. And once a plain text request is received by the server and it sends some response back again, so the response will come here and then the load balancer will do the encryption again. It will do the encryption and then send the encrypted response back to the client. And client can do the decryption and understand the message. So this is what's going to happen. So even if someone got the information here, they won't be able to see anything because it's an encrypted response. Cool. So this is what I want to talk about: load balancer, SSL termination, and then encryption and decryption. And because we are in the AWS network, all these things are like very well connected. This load balancer is connected to a service called as ACM, AWS Certificate Manager, which this is like a managed SSL certificates for us. So we just have to make sure we own the domain, and once we verify like we own the domain, all the certificates, all the public key, private key, everything will be handled by AWS itself. And it has very good integration with load balancer, which we are going to see in this demo. Okay, I think this should be cool. So once this is done, what will happen to this diagram is we'll send the HTTPS traffic here, And then load balancer will use these keys to encrypt and decrypt. It will use these keys to encrypt and decrypt, and then it will send the plain text information to EC2 instance. So all this will be in a secure connection. Cool. Now we'll go into the certificate manager. So the service name is Certificate Manager. Okay, this certificates. There are no certificates here. So I'm going to request one certificate from AWS. So we should enter the fully qualified domain name. So for this domain name, we are going to get a certificate. So our domain name is learn AWS in 30 days .superstats.co. Okay. And I'm going to use a validation method as DNS validation. This validation is important because anyone, like no one should able to get a domain like this. Only who's owner of the superstats.co should able to create a subdomain like this. Else what will happen is someone will say like apa.google.com and then they'll be getting the subdomain out of it. But that is not allowed. Only the owner of google.com can allow a subdomain like apa.google.com. So that is a validation step here, which we are going to do now. I'll say request. Cool. So it's you can see it's pending validation. So if I go into this, you can see like there is a CNAME record here. So how it's going to validate is it will ask us to enter the CNAME and a value in the domain registrar. So if we enter this value, then AWS will go and check if the value is present or not. If the value is present, then it will make sure like, okay, I am the owner of superstats.co and this certificate will be issued. So I'll go to the domain registrar. Okay, so this is a domain registrar. I think I have to show one more thing. So this is a domain registrar and we have something called as NS records. So all these NS records belong to our AWS. So you can see like AWS DNS. So what I'm saying here is Namecheap don't do anything with the DNS entries. Just route all the traffic to Route53. So I'll take care of maintaining all those things. So that's what it means. So we have all this DNS entries here. I'll go to, and if you see this NS record, it corresponds to the NS record which is available for my domain. For example, if I go to my domain, if I type, if I see the NS record here, it is NS1276 -31.org. So 1276 DNS 31.org. So these are the 4 entries which are very specific to my hosted zone. So if I create a new hosted zone, it will have a different NS records. And I have to enter this NS record in the like whatever the domain registrar is. Okay, so now I'm going to create one record here. This record is going to be, this is a CNAME. And the value is this. And this is going to be a CNAME record. Okay, cool. I'll say create records. This will usually take some time because the DNS propagation has to happen and things like that. But once it is done, we'll see the certificate is issued. So here it is in the pending validation state. We'll go back. Oh, that is very fast. So you can see the certificate is issued. And if we go inside, the status is success. Cool now. So we have got a certificate now, but we haven't used the certificate. So we'll see how we can use the certificate in load balancer. So we are going to load balancer and we are coming here. So in this case, if you see, we have one URL, one listener rule, which is pointing to port 80. Port 80 is for HTTP, which is a like plain text protocol. What we want to have is like the SSL protocol. So I'll add one more listener. I'll say the protocol as HTTPS, and by default it will go to 443. 443 is the secure port. Secure port in the sense it's a default port used for HTTPS connection, and 80 is a default port used for HTTP connection. So it's all by the convention things. And instead of forwarding it to another target group and do things like that, I'll return a fixed response. But you can very well forward it to a target group, create a target group and configure all those things. But it will be like a time consuming stuff. So I'll just return a fixed response with 200 and I'll say the content is this is a secure communication to the server. Okay, so this is cool. And once you set the protocol as HTTPS, you have to configure the certificate details also. So it will ask for SSL TLS server certificate. And because we are using AWS application load balancer, it has integration with Certificate Manager. So we can directly import it from the ACM. So I'll just do a refresh. I can see there is one certificate available here. So I'll configure this. And then I'll say, okay, that's it. And I'll say add. So there are two rules now. One rule is saying like it should have the if a traffic comes for 443 port, which is HTTPS port, it should do some logic. If the traffic comes for 80 port, it should do some other logic. Okay, it's saying it's not reachable. Listener port not reachable. Okay, so the listener port is not reachable. The reason for that is, if you remember, like we have a security group. And this security group for load balancer, this is a security group for load balancer. It is allowing only the 80 port. So what we have to do is allow HTTPS traffic also from anywhere. Okay, cool. So we allow this. Now we come here. Okay, it will just take few more seconds, and hopefully it should be like available. But what we'll do in this case is we have this domain, and then I'll go to another domain. I'll say, okay, I'll use Chrome. I'll say something like https:// learn AWS in 30 days. Super starts. Okay, cool. So you can see like the things are configured properly. This is a HTTPS connection. So it's saying like the connection is secure. And you can see it is getting forwarded to the fixed response which we have. And in case if you if you use a HTTP protocol, okay, it's saying not secure, and it will go to the EC2 instance because HTTP 80 is getting forwarded to a target group which will have list of instances in it. Okay, I think like we have almost reached the end of Route 53 and DNS. Cool. I think like we covered almost everything. We talked about Route 53. We talked about Certificate Manager. We talked about the theoretical aspects of it also, how it works and things like that. Cool. If you have any question, please let me know in the comments. And thanks for joining the session. Happy learning. Bye-bye.